Today I've got the venerable Tektronix 2235 scope, and I'm just going to show you some really simple basics on how to set up and use this scope. So this oscilloscope by Tektronix is quite an old one, but it has a 100 megahertz bandwidth. It has 2 channels and also allows you to have external triggers involved so that you can sync with external sources. So first, when you turn your scope on, you might not see the beam, and there's a few reasons for that. One is the intensity knobs could be turned all the way down, and so you just have to turn them up until you can see it. The other issue is this focus knob down here could be out of focus. So let me turn this back on. So if I turn the focus knob, you can see that they get out of focus. If I turn the other direction, they get out of focus. So you might have some weird looking thing on your screen like that, and you say it's blurry. Well, it's out of focus, so we just have to turn the focus knob until we get it nice and sharp. Now this also has this handy button called beam find, and when you press that, it sort of increases the intensity and it squishes everything together. And that's because sometimes your signal might be off the screen somewhere, but you don't know where it is. So you press beam find and it'll show it somewhere on the left, and that way you know it's out here. Now here's a really simple setup. I've got a probe hooked into channel 2, nothing hooked into channel 1, and I've got my probe stuck into this little hole here, which is called probe adjust. And you stick that in there, and you should have a really clean square wave shape. And the reason for this is that some probes have a little screw to adjust the capacitance of the probe. And so you stick the probe in there, and if you don't get a square shape, then you adjust that screw with a screwdriver until you have a perfectly square shape. And in this case, this is a 0.5 volt square wave. So if I zoom in here a little bit more, I'll try to show that. Try to turn this exactly right on the line at the bottom. Out of focus here. So there are 1, 2, 3, 4, 5 boxes. The square wave is 5 boxes high, and if I go over here, I see that I'm on the 10 millivolt range. The 1x is set to 10 millivolts, and what that means is it's 10 millivolts per box. Except it's not 10 millivolts because I'm not on the 1x range, I'm on the 10x probe range. And what that means, if I look here, this probe actually has a switch on it. It says 1x right here and 10x right here, and that allows the probe to measure higher voltages than it would otherwise. It divides the signal by 10. So if I have, in this case I have 500 millivolts peak to peak written here, and that means 0.5 volts peak to peak, and I'm dividing it by 10, so the actual signal going into the scope is only 50 millivolts peak to peak, and so they compensate by that for that by having this 10x probe thing over here. So this is showing 0.1 volt per division. Now that point is pretty hard to see on the camera, but it's there, and so that means this is actually these are called divisions, so there are 5 divisions and they're 0.1 volt each, then that's 0.5 volts high. And lo and behold, that's what it says, 500 millivolts peak to peak. So we take the one peak and the other peak, and the difference between the two is 500 millivolts. Now this also says that the frequency is, well, it says approximately 1 kilohertz, but we should be able to tell what the frequency is if I can get that back in the hole. Also, now let's see. For this, we want to line up, and I'm using the position knob here. I can line up this right on the line in the middle, and we want to get these other sides to fall somewhere convenient. Right now it's kind of at an odd number, so let's try to adjust this and see if we can get this to follow a nice even number. Again, I changed this knob, which is the time per division, like this, and all that does is change how many of them appear on the screen at once. And then I adjusted the position knob like this, and I try to line it up so that corner and that corner are there, and we see 5 boxes, 1, 2, 3, 4, 5. So that is 5 boxes wide, and that means the entire signal, which repeats, is actually it's not 10 boxes wide because that one is chopped off there. It should be 10 boxes wide because this is the 0.1 there's a 0.1 there, and this is the millisecond scale, ms. And so that means it is 0.1 millisecond per box. And if you have 10 boxes, that's 1 millisecond, which is 1,000 hertz. And this is something slightly less than 1,000, I believe, unless we have something else going on here. So the frequency is a little bit lower, possibly, than 1,000 hertz, unless that's a glitch there. Now we can get a more accurate number. Again, I'm turning the time thing. We can get a more accurate number if we do it this way, and try to get a number of cycles in there. So we have 1 cycle, 2 cycles, 3 cycles, and it's not exactly lining up with the boxes. So this frequency is slightly different from 1 kilohertz, as long as this is accurate, which is possible that it's not. Now this has an interesting feature. These red knobs are for calibration. If you want to uncalibrate your settings, which we don't want to, but you can change this way if you have to for some reason. It says to leave it clockwise, and that'll click when you're in what is actually calibrated. It says cal to the right. So if you turn it to the left, let me do this one. If you turn it to the left, and your voltages are changing like this, so you're actually uncalibrated. So we want to keep it calibrated, so we'll keep those clicked. The same thing for the time. You can actually decalibrate the time as well, but why would you want to do that? I don't know. So what you can do though with this interesting knob, it has a little thing that says 10x right on the top here, and if you pull that out, then it zooms in by a factor of 10. If you pull it out, push it in. Now it's a little hard to see here, but if you have so many signals on the screen at once that it's hard to see them all, and you pull this knob out, it zooms in by a factor of 10, and you can see it much more clearly. So that's something that you can do with that particular knob. So the setup for this is as follows. We have this selector switch on channel 2, because I have channel 2 plugged in. If I switch it to both, it'll still show channel 2, but it's also alternating between channel 1, and so it's blinking on and off because there is no signal on channel 1, so it's struggling to find something. And then there's, of course, if we flip this one more time, it goes to channel 1. There's nothing on channel 1, it's just a flat line, so there's not a lot to see there. So I'll flip that back to channel 2. Again, this is the intensity, and I have something called bandwidth limit on, and this is a switch, so you push it in and you push it out, and all this does is limit the bandwidth of the signal coming in so that you get a cleaner signal. Now right here we have a very good source, but if we take this off, maybe we'll see the effect of a band limit. Let's see. Sometimes you have to zoom in here quite a bit. Well, can't quite see it now. But sometimes you'll pick up radio signals, and putting the bandwidth limit on keeps the radio signals out of your measurement so that you can see more clearly. So I also have it set on Alt here, and so there's Add, where it actually adds the two signals together. Then there's Alt, which means it alternates between the two traces, so it shows channel 1, then it shows channel 2. Then there's another one called Chop, and Chop actually breaks it into tiny little pieces, and it switches between both channels by chopping it into small pieces. Chop is actually better for really high frequency stuff, if you have to see something very high frequency. But we'll just leave it on Alt for now, it's fine. Actually, Alt can get really annoying if you have a low frequency signal. So let's say it's really slow. It'll alternate between one channel, the other channel, one channel, other channel. And so for that case, Chop is probably a little bit better. But anyway, let's leave it here for now. And okay, so I also have this set on, there's 3 switch positions here. There's AC, ground, or DC. And I have it on DC right now, which means there's a direct current offset. So if I switch it to ground, I can set the 0 volt point. So this I'll call 0 volts. And then I switch ground to DC. And here it's showing that my signal is actually negative. So 0 volts is right in the middle, and my signal is negative. If I zoom in a little bit here, see My knob is not working so well here. Okay, 0 volts is on the top and minus half a volt is on the bottom. We can also just flip this to AC, and that will automatically put the, so my zero line is right in the middle if I have it on ground. If I switch to AC, now it doesn't have any DC offset, it's only the alternating fields that are shown. And again, there's something, this switch is a little flaky here. I might have to clean that somehow inside. That might just be channel 2. Let's also try channel 1, see how that does. Let's flip this over to channel 1, flip this to channel 1. Okay, we can get our nice signal here. And let's see. So we're on DC right now. Let's flip to ground, and we can see where that signal level is. Let's put it right in the middle for fun. And then we'll, oops, not quite in the middle there. We flip it to AC, and you can see it goes up and it goes down, but neither of those voltages are 0 volts. If we switch it to DC, now this is 0 volts and this is minus a half a volt. AC is useful if you're measuring signals that have a large direct current or DC value. So if you have a 5 volt signal and this is 0.1 volts, you won't see it because you'll have to zoom out like this. It'll be very, very hard to see. But if you switch it to AC, you can just look at the AC component of it, and that's a very useful feature. Now, continuing the tour, we also have these position knobs, which I've been using without really talking about. There's one for channel 1 and one for channel 2. And there's also a left-right position knob that allows us to move it this way so that we can line it up. And sometimes, if you've accidentally turned this knob too far, you can almost be off the screen. And that's what this beam find button helps figure out where your signal is. And you can adjust that to get it back on the screen. Now over here we have all of the tricky stuff to set up. Now this is all the trigger panel, and the trigger is what tells this thing when to display the trace. If your triggering is not synchronized, it'll look something like this. And you won't be able to tell what your signal is because it's just going really fast. So to set this correctly for this display, I have it set to INT for internal, and you can also trigger to line, which is 60 Hertz from your power line coming into the machine, or you can trigger it on external, which is this guy. And so if you have something generating a signal, you can put it in there. At the same time, you monitor it here. So that's very useful for that. And then for the external coupling, it says you can do DC coupling, you can do AC coupling, or you can do DC divided by 10, so that if you have a faster reference coming in, you can see a slower signal. You don't really need that for now. And then this shows whether to go from the internal trigger from channel 1, channel 2, or vertical mode, which I'm not exactly sure what that is, but I have it on vertical mode now and it looks like it's working pretty well. You also have to tell it what level to trigger at. It doesn't know that the signal is from here to here. The trigger might be up here, in which case it would never trigger. So if I turn the trigger level up, well, in this case it's still following it nicely on the screen, but if I turn it all the way down, I start to get some really funny shapes on here because it's not triggering right. It doesn't really know what value to trigger on. So if I increase this, I can get my nice clean signal back. I'm right about in the middle here. And you can change the slope of that trigger source by pushing this button, and as you press that, this will invert because you're either triggering on the low side or the high side, or the low coming up or the high coming down. And so by switching that, you reverse the slope of the trigger. The other things up here, there's single sweep, which every time you press the button it will sweep and you'll only get a blip because right now our sweep is very fast. It's 0.2 milliseconds. If we had a longer sweep, then when you press the button you'll get a longer trigger like that, and every time you press the button it'll trigger. I like the auto one, which is this one, PP Auto, and that's what I was using here to get this nice clean signal. And they have another one called Norm, which I'm not actually sure what the difference is between these two. Oh, norm actually relies on the trigger knob. That's what it is. Sorry, the level knob. So if you put it on auto, it sort of ignores this knob. And if you put it on norm, this knob is really important. And so if I change the trigger level, I can get it to go off triggering if I turn it left or right. So auto makes it a little bit easier. And then there's a thing called B trigger. This one you have a delay here before it triggers. I'm not going to worry about that now. And then there's a thing called hold off, and hold off sort of lets you stabilize the screen. So if I unlevel this, let's put it on norm here, and make it kind of look really bad, and then I increase the hold off or decrease it, sometimes you can get a better signal that way, a better trigger. In this case it's not quite working, but that's something else to play with, is this hold off adjustment. So that's just a real quick basic overview of this machine, and if you set it up something like this, you'll have a pretty easy time getting it to work. Let's try some other setups too. Alright, so for this guy I've got a different setup. I have channel 1, and that's going down to here where my probe is attached to the center conductor of an RCA jack that goes to my headphone jack on this laptop. And I'm on a website right now which is giving me, this is the website, it's a tone generator, and it's giving me a 500 hertz sine wave right now. And so on my screen, which I just bumped something and now everything's messed up. Let's see if I can get that back. There we go. Loose connection. I still have a loose connection. This thing is kind of jittery. But I've got my sine wave up here, and I can change the time base and zoom in on it. I can zoom out on it. And if I change some of the settings on these knobs, I can make it look better or worse. I actually had to change this hold off one to get it to lock there, otherwise it doesn't want to stay locked. So this is showing us a sine wave, and if we want to, we could try to measure the amplitude of the sine wave. And in this case, it's not a focus problem, it's just a jittery waveform here. And so to clean it up, I'm actually pressing the 20 megahertz bandwidth limit, and now my signal got a little bit cleaner. So I'm going to leave that button pushed in for now. And I can try to center this a little bit, and I can count the number of boxes. So 1, 2, 3, 4, and it's a little bit more than 4, I could say 4.1 boxes. And I've got my 10x probe on here, and so that's 50 millivolts per box. So 4 times 50 is 200 millivolts, and it's a little bit more than that, 210, 220 millivolts peak to peak on that sine wave. And we could also try to check the frequency if we wanted to, and I have 1, 2, 3, 4 boxes from this peak to this peak, and we are on 0.5 milliseconds per box. So that's 2 milliseconds for an entire box, and that's the entire period of the sine wave. So that's the part that repeats. So that's the entire wavelength, and so frequency time base there. And so 2 milliseconds, if you invert that, 1 divided by 2 milliseconds, that's 500 hertz. And of course, that's what I have it set at, 500 hertz. Now, cool things you can do here, you can change this sine wave if you hit the right button, and change the sine wave to a square wave. So here's what that square wave would look like. And you can see it's not perfectly square. There's a lot of ripple on the top and bottom. That's because it's very hard to get a perfect square wave from an audio source because there's only 20 kilohertz of bandwidth. And square waves need a lot of bandwidth. Here is a triangle wave, which was just another one that I selected there. So now you've got a nice triangle wave. Again, you can measure the period to get the frequency. You can change the voltage and see what happens there. For example, over here I could drop this voltage. I have it at 75% signal. I'll drop it to 36%, and the triangle gets smaller, or I bring it back up to some higher number. There's 83. So now the triangle got bigger, and there's more on here too. We can generate a different function. We can do a sawtooth And that's what a sawtooth looks like. So it shoots up really fast and then ramps down, and shoots up really fast and ramps down. And so this is all the kind of stuff you can see with that oscilloscope. Really cool. Now, a couple things to be careful of on an oscilloscope. There's a warning here, less than 400 volts peak. So that means you don't want to put more than 400 volts into this. Now this probe, remember, is set on 10x, so that means it divides the signal by 10. So you could have 4,000 volts coming in here, and it'd still be okay for the scope. However, I can tell you that probe can't handle 4,000 volts. So let's not try that. Also, remember that if you hook a probe up to a signal, you also need to hook up the ground. So this little alligator clip here is the ground. And so if you don't hook that up, let me show what happens. So this is with the ground clip, and this is without the ground clip. You got a mess. And if you zoom out far enough, and you change your time base, you can see, you can try to calculate this. 1, 2, 3, 4, about 4 boxes, 4.5 boxes at 2 milliseconds. So that's about 8 milliseconds. Anyway, this should be a 60 hertz sine wave here. So what you're doing is picking up noise from the room if you don't have your ground connected. So let's make sure we got that ground connected to the ground side here, and then we get our nice clean triangle wave back that we can zoom in on. So that's another thing that you have to know, you have to be aware of when you're operating an oscilloscope. The other thing is the ground is actually grounded to the same ground that the whole scope is grounded to, which they provide a hookup here for a banana jack, and that goes to the earth ground in your house. And so if you're trying to do something where you have to measure between two voltages that are not grounded, you can take your channel 1 and your channel 2, and you do add, and then you do invert, and now you're subtracting channel 1 from channel 2 from channel 1. And that way you don't have to worry about ground. You hook up the tip of both probes to what you're trying to measure, and you can measure something that's not grounded that way. So that's just a trick you can do for this. Of course, you want to make sure you have both of these on DC if you're going to try that trick. Okay, I have both channels hooked up now. Channel 2 is going into the calibrator. Channel 1 is still running off of this website on Sawtooth. Let's see if we can get both of them on. Well, we want both, so I'm going to flip this switch to the middle, and now we can see both signals. And this is the adjustment for channel 1, and this is the adjustment for channel 2. And of course this one will shrink channel 2, and this will shrink channel 1, or make it grow. And it also changes the triggering a little bit because we have this on vert mode. We could make it trigger on channel 1 if we switch it up. Now you can see channel 1 is locked, but channel 2 is unsynchronized. Now we could switch it to channel 2, and now channel 2 is nice and locked, but channel 1 is completely unsynchronized. And these are unsynchronized because this is putting out 1,000 hertz from its own reference, and this is putting out 500 hertz from a different reference. We could change this number to a different frequency. Let's just make up a number. 374. Really weird number. So now we've got a different pattern here showing up. Now if we switch this to vert mode, where it tries its best to lock both of the signals, but you can tell it's having a pretty hard time because they're not synchronized at all. They're way off. So if you need to check one channel, it's usually better to just switch this knob. And in this case, we might have to change our hold off level to get that thing to lock there a little bit. There we go. That's better. Actually, almost locked both of them. You can see the square wave one is moving away slightly because the frequencies aren't quite right, aren't matched. I have it on channel 1 right now. If I switch it to channel 2 is locked, but again, channel 1 is going to be bonkers. So, and here it's trying its best to show both, but it just is having a hard time with that because those frequencies aren't synchronized. But you can show two signals at once. Now let's see what happens if we add them. Okay, we add them, we've got a mess here because the frequencies are not synchronized, but you can see that it's trying to add a square shape with that sloping triangle shape at the same time, and you get a really funny looking structure there. And we can try changing this and seeing if we can get a better view of that. That might be a better view there. You can clearly see the square shape, and that's modulating a triangle, sawtooth shape. So it's kind of fun to play with the settings on here to see what it looks like.